So now, well, let me just finish with this part. It says from 1 to 2. There's another arrow from going from 2 to 3, and there's last arrow that goes from 1 to 3. In particular, the relation that we have here is transitive. But how does, what is the new thing that we obtain by introducing these multigraphs and in light of binary relations? Well, let me list just a few things. For example, the property of reflexivity. Well, we have that for all x in A, we have that x in the relation, right? So graphically, once you have a vertex x, then we will see the vertex with a loop for every vertex x. What about the property of symmetry? It says for all x and y in A, if x is related to y, then y is related to x. So what does it mean? Well, that means that if we see this picture, then we will see also another arrow going in the opposite direction. So we will see something like this. What about transitivity? Well, that one states this. If we have that for all x, y, and z in A, if x is related to y and y is related to z, then x is related to z. So what does this mean in terms of graphs? If we see this, then we will see this. So for antisymmetry, which is the last property to be treated here, it says this, for all x and y in the set, if x is related to y and y is related to x, then x is equal to y. Now, how does this look in the language of multigraphs? Well, if we see this picture, then we have that. In other words, the kind of symmetry that we see is very boring. It's only the one that is associated with these loops. Now, we can see ourselves playing with all these other properties and ultimately combining them to obtain pictures for relations that are equivalence relations or relations that are partial orders. So with this, I want to conclude the topic on graphs.